You know, for as long as we've existed, we've looked up at the night sky and asked that one huge question: are we alone? While the European Space Agency is gearing up with a mission that's not just about finding any old planet. Nope, they're hunting for a true second Earth. So let's get into it. This is the PLATO mission.
And really, this is the question, isn't it? It's the ultimate puzzle that drives this entire field. It pushes scientists to build some of the most mind-blowing technology you can imagine. All because we have this deep-down hope that the answer is somewhere out there.
Okay, so to really get why PLATO is such a big deal, you first have to know where we stand in this massive hunt for other worlds. And honestly, the story so far, it's been this amazing mix of incredible success and, well, a pretty deep mystery.
I mean, think about this. Back in the early 90s, we knew of exactly 0 planets outside our own solar system. And now, we've confirmed over 6,000. It turns out the galaxy is just absolutely packed with planets.
But, and this is a huge but, here's the catch. For all those thousands of planets, we still haven't found Earth's twin. Most of what we found are these giant hostile worlds or planets so hot they're literally scorched, or they're orbiting way too close to their star. So yeah, we found a galaxy full of planets, but we haven't found another home.
And that is precisely where PLATO comes into the picture. This mission is a real shift in philosophy. We're moving past just counting planets. The new goal is to actually understand them, to get to know them.
Okay, so PLATO. The name itself is a mouthful: planetary transits and oscillations of stars. But that name tells you pretty much everything you need to know. Its job is to find, and this is the important part, to study planets that look like Earth. And the secret sauce here? It's focusing only on bright stars that are relatively close to us. That's what makes all the difference when you want to study them later.
So you might be wondering, how does it actually do this? Well, PLATO is built differently than any planet hunter we've ever sent up there. It's this super sensitive piece of tech with a really clever way of seeing the universe.
Get this, PLATO is basically a bundle of 26 telescopes, all working together as one. They're all staring at the same patch of sky, which gives it this enormous field of view, way wider than anything before it. It can watch hundreds of thousands of stars all at the same time.
And here's where the real genius of PLATO comes in. It's a two-step process. First, it does the classic thing. It looks for that tiny, tiny dip in a star's light when a planet passes in front of it. That's called a transit. But then comes step 2, and this is the absolute game changer. It stops looking at the planet and starts analyzing the star itself.
How? Through something called astroseismology. It sounds complicated, but think of it this way. PLATO is basically listening to the star. Stars vibrate, they have starquakes, and just like hitting a bell, the way a star rings tells you everything about it: its age, its mass, its exact size. And why does that matter? Well, think about it. You can't say a planet is Earth-sized if you don't know exactly how big its star is. It's all about scale. By nailing down the star's properties, we can finally, for the first time, get a truly precise measurement of the planet.
Now, an idea this big doesn't just pop up out of nowhere, right? PLATO is really the next evolution, the logical next step in a long line of amazing planet-hunting missions. It's truly standing on the shoulders of giants. And this really lays out the whole story perfectly. You had Kepler, which basically answered question 1, are planets common? The answer was a resounding yes. It gave us the numbers. Then came TESS, which scanned the whole sky and showed us the sheer wild diversity of planets out there. But PLATO has a totally different job. It's all about precision. It's zooming in on those bright, nearby stars to answer the real question. Okay, but which ones are actually like Earth?
And man, this mission has been a long time in the making. The initial idea was floated way back in 2007. It got the green light from the European Space Agency in 2014, and since then, it's been this huge all-hands-on-deck effort across Europe. And now, it's almost here. The final cameras are being put together for a launch scheduled in 2026.
So where is it going? Well, its destination is this really special spot in space called the L2 Lagrange point. It's about 1.5 million kilometers away from us, and it's basically a perfect parking spot in space. It's gravitationally stable, super cold and dark, and gives you a completely clear, uninterrupted view of the cosmos. It's the prime real estate for telescopes, which is why it'll be neighbors with heavy hitters like James Webb and Euclid.
So what's the end game here? What's the ultimate prize for all this work? It's huge. It's about finding context for ourselves, for our own place in the universe. Of course, with any mission this massive and this important, there are always some whispers, right? A little bit of behind-the-scenes chatter. You hear things, like some of the first stars Plato is going to look at have already been flagged because they're doing, well, something weird with their light. And there's definitely talk about keeping the first results under wraps for a while, to make sure they get it right and avoid any false alarms. The stakes are just too high.
But then you see a quote like this from one of the mission scientists, and it just cuts right through all that noise. We're not chasing headlines, we're chasing truth. And that just grounds you, It reminds you what this is all about. It's not about a flashy press conference. It's about the slow, careful, patient work of finding out what's really there.
And the actual physical result of all that work, it's going to be a database. But not just any database. It will be the most precise, most detailed map of stars and their planets that humanity has ever created. It's literally the foundation, the treasure map for every future mission that will try to take a direct picture of these worlds and sniff their atmospheres for signs of life.
And that's really what it all boils down to, isn't it? When those 26 electronic eyes on Plato finally open up and stare into the darkness, yeah, they'll be looking for data points, for dips in light, for transits. But on a much deeper level, what they're really searching for is a mirror, a reflection of us. And maybe, just maybe, an answer to that one question we've been asking forever.
Thank you for watching. We put our heart into creating content that inspires, surprises, and helps you see familiar things from a new perspective. If you enjoyed this video, support us with one simple action. Leave a like, thumbs up, and subscribe. It's the best way to show your interest, and it helps us grow, make new videos, and share even more unique stories, ideas, and discoveries with you. Your feedback isn't just numbers under a video. It's what motivates us to keep going. We truly value your time and do our best to make every minute you spend on this channel something more than just watching, something memorable and meaningful. There's much more ahead. Fascinating episodes, fresh research, unusual discoveries, and real stories from the edge of science and imagination. Don't forget to turn on the bell so you'll be the first to know when a new video drops. Thank you for being here with us. See you in the next one. It's going to be an exciting journey.